Hi Math, I'm Andy. So today we're going to look at the limits at infinity, and we're going to show you the algebraic approach. Now, taking a calc class or a trigonometry class or an algebra 2 class or a math analysis or some higher level math class, you may learn the rules for finding horizontal asymptotes. You want to look at the degrees of the numerator and the degrees of the denominator. But let's say that you have no idea what I'm talking about, and you just want to know what's the limit as x approaches infinity of this function 4x plus 1 over x plus 1. Well, your technique or your strategy is going to be, number one, you want to always try the direct substitution. And what I mean by direct substitution is you're going to take that thing that you're finding the limit of and you would just straight plug it in. So this would say, we would do direct substitution. We would have 4 times infinity. So we'll just kind of use multiple colors. 4 times infinity plus 1 over infinity plus 1. Now, you may have a younger sibling that is like, well, infinity plus 1, infinity times 100. But it turns out the rules of infinity is 4 times infinity is still infinity. And infinity plus 1 is still infinity. And so 4 infinity plus 1 would actually have a value of infinity. And infinity plus 1 is also infinity. And in math, we don't want infinity over infinity as an answer. It actually doesn't work for us. So our direct substitution isn't going to work to find this limit. So we have to take a second approach, and I call it the algebraic way. Now, we're going to do some manipulating of this function. What I'm going to do is I'm going to take this 4x plus 1 and x plus 1, and I'm going to multiply the numerator and the denominator by the value of 1 over x. So I've chosen 1 over x because it matches the degree of the highest variable. So my variables are both have a degree of 1, so I chose 1 over x because I wanted to match those degrees. And we'll show you why. Now we're going to take this value, because I multiplied the same number on top and bottom, it doesn't actually change the values of the function. Like when you multiply 1/2 times 3 over 3, you get 3 over 6, which is still a half. So this 1 over x is going to get distributed to each piece of the numerator and denominator. So this is going to give me a 4x over x plus a 1 over x. And then in my denominator, I'm going to have x over x plus 1 over x. And I'm still taking this limit. So really this limit as x approaches infinity is still there. The limit as x approaches infinity is still there. I'm just kind of manipulating my function. Now I can do some algebra here. I have the same value on top and bottom, and so they're going to cancel each other out and become 1. So I now have the limit as x approaches infinity of 4 plus 1 over x and 1 plus 1 over x. And so this function and my original function are the exact same. They just look a little different, but that difference is going to be what helps us solve this. Because now I can go back to this direct substitution and I can take this limit value and I can plug it in. And when I do that, I get 4 plus 1 over infinity and 1 plus 1 over infinity. Now, the reason why this is going to be helpful to us, because 1 over infinity, we can just say has a value of 0. Because I want you to think about that, infinity in your denominator. Let's kind of think about these numbers. 1 over 1 is 1. But 1 over 2 is less than 1 over 1. That's a half. And then 1 over 3 is even less than 1 over 2. Like if you have a circle and you cut it into 2 pieces, or you have a circle and you cut it into 3 pieces, those pieces start to get smaller and smaller. So I just want you to notice that as my denominator keeps getting bigger, the actual value of that fraction gets smaller. So when I take a circle and I cut it into an infinite number of pieces, which is impossible, I actually have nothing left. It's all cut up and gone. And so we can say that 1 over infinity is 0. Now why this is helpful for my function, because if I replace 1 over infinity with 0, I end up with the question of what is the limit as x approaches infinity of 4 over 1. And when you take the limit of a number, the limit of a function, of a constant, it's equal to the value of that constant. So in this case, the limit as x approaches infinity of 4x plus 1 over x plus 1 is equal to 4 using our algebraic method. Now again, as you continue your studies of calculus and your studies of limits and in your studies of asymptotes and horizontal asymptotes, you're going to learn some rules that you can investigate. Now the rule that's happening here, just to kind of give you that, is we look at the highest degree of our numerator and our denominator. In this case, the degree is both 1 and 1. And when your degrees of your numerator match the degree of your denominator, the limit is going to be the value of the ratio of the leading coefficients. And so in this case, my leading coefficient is a 4, and my leading coefficient is a 1, and that is exactly what we figured out for our answer.